The next topic is three new computing paradigms. First one is service-oriented architecture, that is SOA and Web 2.0. The service-oriented architecture helps different online services work together smoothly, and it allows websites and apps to share data and functions, making them more interactive and user-friendly. For example, when we log into a website using our Google or a Facebook account, service-oriented architecture helps connect those services seamlessly or continuously. Then second one is virtualization and cloud computing. Virtualization allows one computer to act like a many, making it easier to share resources. And this has helped create cloud computing where we can access storage, apps or processing power over the internet whenever we need it. Just like a streaming of movies instead of downloading it. The third one is Internet of Things, that is IoT. IoT works because of technologies like RFID. RFID, that is radio frequency identification, which used for tracking items, and GPS, that is global positioning system, used for locations, and sensors used for collecting data. These technologies help everyday objects like smartwatches or home appliances and cars connects to the internet and communicate with each other, right? For example, a smart fridge can tell you when you are out of milk by sending a notification to your phone. The next topic is computing paradigm distinctions. Yes, that means the differences between various computing models or approaches. Yes, it helps us understand how different types of computing like cloud computing, grid computing and IoT work and what makes them unique. Yes, for example, cloud computing provides online services and grid computing connects multiple computers to solve big problems. And then IoT connects smart devices to the internet, right? So centralized computing. Centralized computing is a system where all computer resources like a processor, memory, storage are located in one single physical system. Yes, everything is managed from a single powerful computer and all users and devices connect to this central system to perform a tasks. Yes, then one integrated operating system controls the entire setup here. So the next point is many data centers and supercomputers are centralized systems, but they are also used in parallel, distributed and cloud computing applications, right? Centralized computing used in supercomputers are used for scientific research, simulations and data analysis. Then in data centers to store and manage vast amounts of information for businesses. Then old mainframe systems used by banks and government agencies, right? So the next is parallel computing. If you are getting confusion, then pause the video and make a note. See, parallel computing is a method of where multiple processors work together to solve a problem faster by dividing the tasks among them. Right? All processors are either tightly coupled or loosely coupled, right? So these are the types of parallel computing. In the tightly coupled, all processors share the same memory, but in loosely coupled, each processor has its own memory and communicates via messages. Then example for shared memory is a team working on one big whiteboard. But example for distributed memory is each team member has their own notepad but they share information. Yes. Then how do processors communicate? In shared memory, all processors access the same data like a common chalkboard, right? Then in message passing, processors send the data to each other like emails between teammates. The fact is, supercomputers like IBM's Summit and Frontier use parallel computing to process trillions of calculations per second. The next is distributed computing. So distributed computing is a branch of computer science that focuses on how multiple computers work together as a system. Then the next point is distributed system is made up of many independent computers, each with its own memory, and they communicate over a network. The next is these computers share information by sending a messages to each other over the internet. The next point is a computer program that runs in a distributed system is known as distributed program. That means a programmer designed to run on a multiple computers within a distributed system is called a distributed program here. Yes, the next point is the process of writing distributed programs is referred to as a distributed programming. That means creating a software that runs on multiple computers in a distributed system is called a distributed programming. Yes, the next is cloud computing is a technology that allows the users to access a computing resources like a storage, servers and applications over the internet instead of relying on their personal computers. Okay. The meaning of this is cloud computing can work as a single powerful system that is centralized or as many connected computers working together. Yes, that is distributed computing system. Yes, then next, the cloud computing can process tasks using multiple processors at the same time. That is nothing but parallel or by spreading tasks across different computers. That is distributed computing. The next is cloud systems can use a real computers or a virtual machines and they can be set up in one location that is centralized or across multiple locations that is distributed. The next point is some experts see cloud computing as a way to provide computing power like a utility or as a service that users can access it on demand. Thank you. We'll continue in the next video.